Okay, good morning. Team Impact had a good review in class. If you're watching it, something happened, but if you're at home, we're going to be multiplying fractions. In the warm-up, there's a fact sheet, and on the back of it, which would be the second page, is a couple problems that we did, but we did some rapid fire and so on. So let's get started here. Let's get rid of this top piece, all right, and let's get into the vocabulary part. In order to multiply fractions and mixed numbers, each number must be written as a proper or improper fraction. And we've been working on those things, right? Mixed numbers must be converted to improper fractions, and whole numbers must be written over 1. We'll talk about all these things, right? Okay, steps for multiplying fractions. Change each mixed number to an improper fraction. Multiply the numerators. Multiply the denominators, and I'm going to abbreviate. And then we simplify. Okay? So go ahead and kind of get caught up there a little bit if you could, and we're going to continue on in just a minute. Now, when we multiply fractions, all right, we're going to want to look to factor, okay, and that's where those mental divisibility rules are going to come in and really help us, okay? So, first one. The first thing I do when I look at a multiplication of fractions is I look for a top to bottom combination that, excuse me for a second. Sorry about that, I started coughing. I look to factor out a number that's, excuse me, that has a common factor on top and bottom. And I see nothing, all right, in these first two problems. So let's make it real easy. To multiply fractions, we're going to multiply the top numbers, we're going to multiply the bottom numbers, and look to simplify. 2 times 4 is 8, 3 times 5 is 15, and that is simplified, right? Next one, all right, and you don't need to do this step. Let's take that step out now. 6 times 2 is 12, 7 times 7 is 49, and let's circle it. Pretty easy stuff so far. Nothing earth-shattering. Again, multiplying the numerators and multiplying the denominators. Let's flip it over. Now, when we get to the next page, all right, let's fill in the little vocabulary up here. Common factors between the fractions can be simplified. All right, can be simplified. Excuse me, I keep coughing before the multiplication. Okay? Excuse me. So, this is what we're looking at. We're looking to factor, cross-reduce, cross-cancel, whatever you want to call it. Okay? So let's get rid of this and let's take a look at this problem over here. It's the same one. Over here, I'm looking for a top to bottom combination. The first thing I will tell you when you look to factor is you're looking for the same number on top and bottom. We're going to divide those by 3. Over here, 2 and 4 are compatible. 2 goes into both of those, right? 2 goes into 2 once. 2 goes into 4 twice. So now, 1 times 1 is 1. 1 times 2 is 2. And I circle it. So it's a lot easier. It's a lot easier to do it this way. And I'll go back here, and I'll go back. Look, if I didn't go back, look what would happen. And I didn't reduce. Then I would have to reduce it on the back end. So you end up with the same answer. It's just a little bit easier. I do want you to do this because that's going to make your life a lot easier. All right, number 4. Let's go. 4/9 times 3/4. Anytime you see the same number top and bottom, cancel them out and put 1. Remember, when we reduce, it has to be a top to bottom combination. 3 goes into 3 once. 3 goes into that 3 times. 1 times 1 is 1. 3 times 1 is 3. And it's just that easy. So factoring is going to help us. It is. And on Monday, we're going to do a lot of this, all right, because we have a quiz Tuesday. Next one up is unique because we have two whole numbers. Now, or excuse me, we have two mixed numbers. And when we have mixed numbers, we have to get them to an improper fraction. So as we did in our rapid fire warm-ups, we're going to multiply and add. 2 times 2 is 4, plus 1 is 5, times 5 times 3 is 15, plus 3 is 18, and the denominator doesn't change. Now, at this point, we can do our factoring. We can cancel out. And I clearly see 5s, right? 5 goes into 5 once. 5 goes into 5 once. 2 goes into 2 once. 2 goes into that 9 times. 1 times 9 is 9. 1 times 1 is 1. Any number over itself is that number. Okay? So we're looking at all this, taking it all in. Not too bad so far. All right. Let's take a look at number 6. Number 6 reads, a recipe calls for 2.5 cups of sugar. If Mrs. Marina is going to make 1/2 of the recipe, how much sugar does she need? So we need half of that. So half of means to multiply. So half of 2.5. So the next thing I'm going to do is rewrite this as an improper, and I'm going to rewrite the whole thing. 2 times 2 is 4, all right, plus 1 is 5 over 2. Now, you'll notice here that there are 2's on the bottom. We don't cancel that, okay? All right, because it has to be a top to bottom combination. 1 times 5 is 5, 2 times 2 is 4. And we need to switch that back to a mixed number. Okay, and when we do, this is a mental problem. 4 goes into 5 once. 5 minus 4 is 1. The denominator doesn't change. How much sugar does she need? Well, she needs 1 1/4 cups. And we want to label that. Okay, let's move on. Next problem. A rectangle has a height of 1 1/4 inches and a base of 5/6. What is the area? Anytime we're looking for the area of a rectangle, area is going to equal length times width. Length times width. Base times height. It's the same thing. So let's get set up. All right, 1 1/4 times 5/6. Yes, we need to switch that to an improper. 4 times 1 is 4, plus 1 is 5. 5/4 times 5/6. Again, we're looking for a top to bottom combination, and I see none. We're not allowed to reduce top to top. 5 times 5 is 25. 4 times 6 is 24. Now, can we switch this back to a mixed number? Yes, and I'm going to do my work down here. So I'm going to go ahead and divide that out. It's a little bit bigger. 24 goes into 25 one time. I subtract and get 1. That is my numerator, and my denominator doesn't change, and the area is in 1 1/24 inches square. Area is always what we call square units, all right? It's how much space it covers. I'll let you get caught up there a little bit. Pull that up a little bit for you. Okay. We have a few more problems here. If you want to pause the video and go ahead and do it, you can. I'm going to continue on my path. Let's go. 4 students were each given a card with a fraction on it. Okay? They were asked to pair up with another student and multiply the fractions. Okay. When Omar and Andre multiplied their fraction cards, they got a product, that's the answer to a multiplication problem, greater than 4. Omar, Andre, let's go. 1 3/4 times 1 5/6. Let's take it to impropers. 4 times 1 is 4, and 7/4 times 11/6. Now, no top to bottom combination. Let's multiply it through. And now we need to switch it back, right? So I'm going to come over here and kind of set it up a little higher, like that. Top number falls inside the house. 24 goes into 7. No, but it will go into 77 3 times. 3 times 4 is 12. Carry the 1. 3 times 2 is 6, plus 1 is 7. Subtract and get 5. My pencil. That is my numerator, and my denominator doesn't change. So, do they get a product greater than 4? Absolutely not. That is false. That is false. If Era multiplies our fraction card by any of the other cards, the product will always be greater than 1. True or false? Well, if Era multiplies, let's see here, 1/5, right? If she multiplies her 1/5, will the product be greater than 1? Excuse me. The product will always be less than 1, excuse me. If Era multiplies her fraction card by any of the other cards, the product will always be less than 1. All right, so let's take a look at this. When we take a fifth of a number, and let's just talk about this without multiplying all those through. When I take a fifth of a number, all right, I'm taking really a fifth equals 2/10. I'm taking a piece of that is clearly less than 1, and it's less than a half, right? So when we look at all of these, all right, okay, when we look at all these, let's look at this, right? Yes, that's going to be true because, all right, if I take half of that, it's less than 1. Over here, if I take half of that, right, it's going to be less than 1. The question is Ellie, all right? It's a little bit bigger. Excuse me. And let's find that out. So let's take 1/5 times 2 2/7. 1/5 times 14, 15, 16 sevenths. So that equals 16 what? 35ths. Is that less than 1? Yes. So that was the only one that was in question. And in fact, any number less than 5, if you take a fifth of it, is going to be less than 1. So that is true. That is true. Last one. When Ellie and Omar multiplied their fraction cards, their solution was between 2 and 3. Ellie, Omar, let's go. 2 2/7 times 1 3/4. 14, 15, 16, all right, over 7 times 4, 7/4. Oh, this is setting up beautifully to factor. Now I have the same number top and bottom. I cancel it out. 4 goes into 4 once. 4 goes into 16 4 times. 4 times 1 is 4. All right, over 4. All right, is there a solution between 2 and 3? No, it's greater than 3. It's 4. Okay? So some good math today. If you flip it over, you can see the next page is your homework. 1 to 8, or excuse me, 1 to 9. It is. Match the letters, match the answers and put your letters in. All right, and see. All right, how do you get, what do you get if you divide the circumference of a jack-o'-lantern by its diameter? Let's see what it is. Have a great day, guys, and a great weekend.